All right, you have seen the right answers up to and including number 4 on page 166. So, let's bring it home, people. What's the answer to 5? 6x cubed y 4x minus 3. What's the answer to 6? 7. Put a star by number 7. Because we're coming back to that today. Number 8. 8 is where it starts to get a little bit tricky. X plus 3, x minus 2. Is there anybody in the room that did not do that question because they weren't sure of how to do it? Or worse, you distributed that x, then you distributed that 3, and then tried to factor it. All right, so let's talk about that right now. If you distributed, you got x squared minus 2x plus 3x minus 6, yes? Which got you x squared plus x minus 6, right? Which got you numbers that multiply negative 6 and add to 1 are x plus 3 and x minus 2. Agreed? All right, good. Now, look at what I am about to highlight. Does everybody see what I've highlighted? Do you see how that highlighting applies to the answer? Why? Let me show you why. What math is happening right there between 24 and x? Excellent. What math is happening right there? What math is happening right there? Which makes this a factor, yes? Because it's something times something else. What do those brackets do to x and negative 2? Holds them together as one unit, yes? Which means this whole thing is a factor, yes? What's this? That's another factor. Why do they use a different color? Because it's a 3 and that's an x. They're not the same. But what's this? The same factor. So, isn't that and that a common factor? Which means, since there is a common factor, would I not be allowed to divide out that common factor, write it at the front, and then put the answers over here, just like GCF factoring? Does everybody see that? Does everybody see how it is infinitely less steps? Not really infinitely less, 5 less steps. But for a class that asks for more time every chance they get, should you not be looking to save time? Now, let me show you something else that will make your life forever easier if you can understand it. Watch. A equals x minus 2. What do you see right there? X minus 2. But I told you A equals x minus 2, didn't I? So isn't this XA? Okay. Plus, what's that? X minus 2. But x minus 2 is A, correct? So is that not 3A? Now, does it not become quite obvious that A is in both of them? So A can move to the front, leaving me with x plus 3. But there is no A in that equation. A is x minus 2. So what would I write here now? X minus 2. X plus 3. This is a wonderful math gift that I have brought to countless classes. In those countless classes, there's like 10 kids that use it. Why do you think I show you this trick? Why do you think I waste my time and yours by showing you that? Manru? Because it's a useful trick to know. And yet, nobody bothers to use it. If you wish to distribute all the time and try to factor, by all means keep doing it. But I guarantee you, you will come into trouble doing that. If you use this move I just gave you, it will make your life infinitely simpler as you go forward with factoring. But it is a gift, and just like a real gift, you don't have to use it. Okay? Please notice in number 9, it would be very helpful, wouldn't it? Because if I make this Q, and I make this Q, then don't I have 2AQ plus BQ? And isn't it quite obvious that Q would come out, leaving me with 2A plus B? And isn't it quite obvious that there is no Q in the original equation, but Q is indeed A minus B? And that took 1 second, as opposed to distribute, collect like terms, factor. Okay? There's a reason I didn't show you that trick first, because I expected all of you to distribute and factor, which actually makes you practice factoring. But when you think about it, making that A and A or Q and Q or P and P or whatever the heck you want, isn't that also factoring? So it's still practicing factoring, yes? Now, what makes 10 weird? Those are not the same, are they? But they're pretty darn close, aren't they? What is the difference between the yellow and the green factors? Eka.
On the left, 3 is negative, and the right, 2x is negative.
Right. Over here, 2x is positive. Over here, it's negative. Over here, it's 3 negatives. Over here, it's 3 positive. Is there a way to change the way the green one looks, but not change its value? What is the number that I can do anything with that doesn't change a value? 1, right? So if I bring out a 1, then there'd be a 1 out front and 3 minus 2x, yes? That doesn't help me. What if I bring out a negative 1? What would I get? Negative 1, and I would have, what's 3 divided by negative 1? Negative 3. What's negative 2 divided by negative 1? Positive 2x. Now, if I distribute this back in, do I get positive 3 and negative 2x? So is this the exact same as that? Yes. Everyone sees this? Okay. But there's already a negative 5 there, and now there's a negative 1. What must they do? Multiply together because they're coefficients, yes? So what do I really have there? X, 2x minus 3, plus 5, and then what? 2x minus 3, right? Positive 2x, negative 3, negative 3. Now I can go back to this move that I don't even need to write down because I can see it. Obviously, there's my A and A. A comes out, leaving me with x plus 5. A is 2x minus 3 and x plus 5. Now, if you had distributed this out, you would have had a long, hard row to hoe, which is an old person saying for it's really hard work. Everybody cool? Now, these 3 show 3 very useful factoring tricks. Those 3 things are kind of like the Swiss Army knife of factoring. You can use them in all kinds of situations whenever you need to make something look prettier for you to deal with. Damn it. Prettier for which you will have to deal. You don't want to dangle your prepositions. And with is a preposition. Now, of course, the last two questions were just multiplying, just to remind you of how to do it. How do I do this? X plus 3, x plus 3, x plus 3. It is not x cubed plus 27 because this means that is the base. So the base must be repeated thrice. So it is indeed x cubed, but it's hard to do all at once. So I like to do it in two stages. X plus 3, but then I do this one. X squared plus 6x plus 9. Remember, 3 plus 3 is 6. 3 times 3 is 9. It's that little other shortcut that is handy to use. Then I distribute again. X cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27. Then I collect my like terms to get x cubed plus 9x squared plus 27x plus 27. And then this one is, of course, just double distribution. You know it is FOIL. I don't like calling it FOIL. 10x squared minus 6xy plus 20xy minus 12y squared to get 10x squared plus 14xy minus 12y squared. And that is where you should be right now. Is everybody good with the first two kinds of factoring? Yes? What are those two kinds of factoring? GCF and trinomial factoring. Yeah? Yeah. Okay. Turn the page over to whatever page we are on, 167. You already know how to do this one. But this is the one where the most tricks, the most pitfalls, the most things that can mess you up happen with this one, even though it's one of the easiest ones to do. If I told you to expand that, what would happen? X squared minus 4x. I know it's blue, just keep talking. Plus 4x minus 16. What happens to the middle terms? The linear terms. They drop out, and I get x squared minus 16. Now, on the previous page, you saw this as x squared minus 0x minus 16, yes? Okay. And I said it's there to show you that even though it's 0, you can use 4 and negative 4, right? To remind you that those factors exist. When you're listing factors, 1 and 16, 2 and 8, you got to remember 4 and 4 are part of it, right? Now, what can you tell me, mathematical characteristically speaking, about those two terms? They are both perfect squares, right? X squared has a square root. What is it? X. 16 has a square root. What is it? 4. What can you tell me about that mathematical operation? It is subtraction. Subtraction leads to what answer? A sum, a difference, a product, or a quotient? A difference. Subtraction. Now, notice the title of today's lesson. You don't need to see it on the screen. It's written on paper in front of you. What is the title of today's lesson? Difference of squares. So, please notice I started with a square. I subtracted another square. And notice that the answer was the square root of the first term plus the square root of the second term, and then the square root of the first term minus the square root of the second term. Does everybody see that? So I'm going to write it in a formula for you. A squared minus b squared. Right? Now, in this case, a squared was x squared and b squared was 16. But 16 is really 4 squared, isn't it? Isn't it? Okay. So a squared minus b squared works for us, right? And the answer, when you factor it, is always the square root of a plus the square root of b, and then the exact same thing with a minus sign. Okay? Now, let me ask you this. Does that have a square root? Yes. Does that have a square root? What is it? X squared. Does that have a square root? What is it? X cubed. Does that have a square root? No. It does not. Now, Eckham was seeing a pattern. He was saying, oh, yeah, 4 divided by 2, 6 divided by 2. Yeah, I got you. That is going to be x to the 3.5, which is x is 5 over 2, correct? 5 over 2 is the square root of x to the 5th power. That's not rational, is it? So that's why the odd one has no square root. Everybody cool? All right. So this first one is actually about the second hardest kind of this question I can give you. And I'm starting with that because it's that easy. So let's look at this first question. Is it a difference of squares? How do you know? Because there's a subtraction sign. Excellent. They both have square roots because that is what kind of exponent? Even. And if it's even, it must have a square root because 8 and 8 will make x to the 16th, correct? So, follow our little formula here. What is the square root of that? X to the 8th. Plus, what is the square root of 1? 1. Then what do I write? Same thing except minus 1. Am I done? Of course not. Why am I not done?
Negative 1 and the x
8 minus 1. I have to continue. Do I forget about this guy? X to the 8th plus 1. But this guy breaks down now into what? And then? No. Minus 1. Now what? Am I done? Why not? I got to go again. What's this one going to be? Am I done? No. Why not? Now what? Am I done? Yes. I started with a hard one on purpose. Everybody good? What if I changed this to 256? What would this first one be? 16 and 16. Then what would the second one be? 4 and 4. Then what would the third one be? 2 and 2. Then could I go on? No. Why? Because 2 doesn't have a square root. Everybody cool? Please notice, it's this that you already knew what to do. We just do it again and 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 again until I can no longer do it. What looks weird in number 2? There's 2 of them. What is the way I always tell you to solve a problem that confuzzles you? Same thing I always tell you to do, Manroot. If it happens once, it happens all the time, right? Would I ever give you a question you can't do? No. If this looked like that, could you do it? What would it be? X 15 and x minus 15, correct? Okay. If it looked like this, what would it be? Y plus 15 and y minus 15. So that's the answer. Why is it the answer? Mr. Mudge, did I do it right? Did I do it right? Kid, did you? What's xy times xy? X squared, y squared. Right? What's 15 times negative 15? Negative 225. And since one's plus and one's minus, we know the middle term's going to drop out, don't we? Everybody cool? Easy peasy lemon squeezy, right? Okay. What's 3? Is it a difference of squares? How do you know? 144 has a square root and z to the 8th has a square root. What is the square root of z to the 8th? Plus, what is the square root of 144? Then what? Am I done? Of course I am. Why? 12 has no square root. Right? Okay. What's weird about 4? There's coefficients. Blech! Right? But, again, if it was that, what would the answer be? X cubed plus 5 and x cubed minus 5, correct? Okay. What if it was that? 2 plus y and 2 minus y. So what do? Does anything change? No, because this is a perfect square, isn't it? Because this is 2x cubed times 2x cubed to get 4x to the 6th. This is 5y times 5y. Everybody understand? Now, do you technically have all the knowledge you need to do every permutation of this right now? Yeah, you do. Do you think you're ready to do every permutation of this right now? Of course not. That's why you have half a blank page. Don't jump the gun there, sister. Would I ever leave that much white space? Right. Let's show you some of the ways that this can mess you up. First one, the easiest thing I can do to mess with your head. X minus 2 squared minus 4. How many of you immediately jump to distribute that? Good, I hope not, because what do those brackets do to x minus 2? They hold it together. So isn't this a squared minus 4? Isn't it? Okay, so what's the answer? A plus 2 and a minus 2, correct? But what's a? X minus 2 plus 2. What's a? X minus 2 minus 2. What's x minus 2 plus 2? X. What's x minus 2 minus 2? X minus 4. Done. No distribution. Easy peasy. Right? Everybody cool? Okay. Now let's do this one. Oh! Sorry. 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 I apologize. There we go. What are you going to do with that? Does that look like I should be able to do a difference of squares to it? Doesn't? Oh, sure you can. Because what are you supposed to do first? What's the GCF? 8 what? What's 8x to the 7th divided by 8x? X to the 6th. What's 32x divided by 8x?
4.
Minus 4. Now what? What's that? And? That's the next trick I can pull on you. Everybody still good? Okay. Third trick I can pull on you. This one. What's that? Right. It's just reversed order, isn't it? Is it still A and B? Are they both squares? So does anything change? 9 plus 2y. 9 minus 2y. Everybody's still good? All right. Now the final and most yucky trick I can pull on you. This hurts me to even do this to you. It does. Why, Mr. Myers? Why? Why do you do it to us? Yes, it is just. There's a real good hint right there that you could do. What's this? Make that what? A. Okay, A squared. What's this? B squared. Can I factor that? What's the square root of A squared? A. plus what's the square root of b? B. Then what? A minus b. What's a? 2x minus 3. Plus what's b? 3x plus 2. What's 2x plus 3x? 5x. What's negative 3 plus 2? Negative 1. What's a? Minus. What's b? What's 2x minus 3x? Negative x. What's negative 3 minus 2? And I'm done. That's the hardest thing I can do to you. Now, are you allowed to distribute that, collect your like terms, and factor the resulting polynomial? Are you allowed to do that? Yes. But it is more steps. Everybody cool? That is all the permutations of the difference of squares. Yeah? Excellent. You are working on page 168. And that's it for now. We'll see how well that goes. Go. Answer I have. Stop talking to your friends and ask. Please notice that order doesn't matter, yes? Ooh, number 10. Interesting. Yeah. Oh, you reverse it from me. I like to put the biggest one first. Done. Right? All right. What's the next page in your people's books? Make sure I'm on track. What? The fourth trinomial factoring, yes? Excellent. Good. We will.